In this video, I will explain you methods of charging a body. We have got two methods here, charging by conduction and charging by induction. Now, as the name suggests, charging by conduction is simply bringing a contact with a charged body and charging the other body. So, let's say we have a charged rod. It has got 12 excess electrons, so minus 12 is the charge. Now, what will these electrons do to other electrons? These electrons will be repelling. So this will repel this electron, this will repel this electron. So this is repel. Here inside the conductor there are repulsive force in between all the electrons. So these electrons will be spread across, keeping the maximum distance with other electrons. Now the moment you are bringing a contact with other body, thing is, see, now these electrons, after repulsion, it has got one more space to go. See, now these electrons, with these electrons, these two electrons are repelled by all 10 electrons. Now, in this case, this electron can go out. But here in this case, this electron cannot go out because the whole thing is conductor and it has to reside inside. The moment it goes out, there is some process to take it back. Anyway, charges will only reside with material. So there are no material outside. It cannot go out. So only possibility here is this electron can go from this material to other material. For that we need a contact. It cannot jump. So what will happen when we are bringing a contact here? Now these two electrons are repelled by these two electrons and all other electrons behind it. So these two electrons will go inside. And with this material, we know what is the net charge. This has got a net charge of 0. Why? The number of electrons and number of protons are same, or number of positive charges and number of negative charges are same. So initially the charge is equal to Q is equal to 0 here. Here in this case Q is equal to minus 12E. 12E basically, 12 into charge of an electron. Yeah, minus 12E I can write in this way. If I am saying minus E is the charge of an electron. So this electron will repel and now this electron will go to the uncharged body. Now it has got 2 excess electrons. Okay, now again these 2 electrons are repelled by other, how many electrons? 1, 2, 3, 4, 8 electrons and more 2 electrons will come here. But you see a change here. Now inside the uncharged body, electrons are getting excess. See, previously there were no excess electron. Number of electrons and number of positive charges are the same. Net charge is equal to 0. But here in this case, see, when 2 electrons come inside, there are 2 excess electrons. Now these 2 electrons have gone from here. Now one more 2 electrons have came. So 4 excess electrons. Now these electrons will also repel the incoming electron here. Okay, so it has got how many electrons here? 8 electrons, but here 6 electrons push these 2 electrons inward and we have only 4 electrons here. So what will happen? This force is more. So this 6 electron will be able to push 2 more electrons inside. So what is the net charge here? See, from here 1, 2, 3, 4, 5, 6. 6 electrons have came inside. Now we have 6 electrons here. Can it push more electrons inward? No. Why? Because when we are, let's say these 5 electrons are pushing these electrons inward, but the 6 electrons is pushing it backward. The net force is 0. Now more amount of charge conduction cannot happen here. So what will happen here? What is the reason? When we brought contact, electrons have gone from one material to another material till this point. This is called as a point where both attains the same potential. We will learn in the coming chapter. Now see, the second method is induction. But in induction, I will read the definition for you. When a charged body is brought near to an uncharged body, uncharged conductor, the free charges in the conductor is polarized. This is called as charging by induction. See, we will picturize it. So let's say we have a charged body, same thing, that has got 12 electrons, excess electron. When it is brought to a material, and let's say this material has got initially a net charge of, say for example, 6 electrons, 6 minus charge and 6 positive charge. So what is the net charge? Net charge is 0 because 6 positive and 6 negative charge. Now the moment we are bringing a charged body to an uncharged body, what will happen? These positive charges will be attracted by the negative charge. See, we have positive charges here and we have negative charges here. So these positive charges will be attracted to this side and these free electrons will be repelled to the other side. As it is conductor, this is possible because conductors allow charges to move across. So what will happen? What is the outcome? Outcome is we have a charged body 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So when we are bringing it near to an uncharged body, the positive charges will come here. Why? Due to attractive force. Unlike charges attract, like charges repel. So 6 charges will go here. 6. This is called as polarization. So this is polarized and this process of charging is called as charging by induction. But see, now also the object is not charged. How can we say it as charged? Unless there is a net charge. What is the net charge? Here in this case also net charge is 0 because 6 positive charges and 6 negative charge. Previously also it was 6 positive and 6 negative. It is not charged here. It is just polarized. Okay, but this side is charged, right? So this is an induction. But the total material is not charged here. I can charge it by simply sending the negative, these electrons to earth by connecting this side with earth. What will happen? This electron will go to earth and making the net charge here at this place is equal to 0. So what is the total charge of this material here? 6 positive and 0 negative. That is in total 6 positive charges. And now we can distribute the all 6 positive across the material. How? Now why the positive charges are staying here? Because it is attracted by the negative charge, the charged body. The moment you are keeping it far away from the positive charge or from this material, what will happen? Now these positive charges will interact in between and that will be spread across as like this. 1 positive, 2, 3, 4, 5 across. Now this is an outcome of induction. Okay, so there are polarization and there are process like this to while charging a body. Here in this case, when we are just keeping it near to this, the whole material is not charged but one side is charged and the reason is induction here. This has induced a charge at one end. Now one more interesting thing from this is when we are bringing an charged body near to an uncharged body, so polarization will occur. All positive will come, 6 positive here and 6 negative here. Will there be a force in between these two? Yes. Why? You know, these 6 charges are attracting the positive charges towards it. Now as the distance is less, the force will be more. Okay, so it is higher attractive force. Now here in this case 6 negative charges and 6 negative charge. There will be repulsion, but the problem here is 6 negative and 6 negative at a distance. As compared to these two, 6 negative and 6 positive, it is close to each other, but this is far away from each other. So here repulsive forces will be there, but it is comparatively lesser as compared to the attractive force. So this will have a net force in this direction. But generally the object will not come with force because electrostatic force is a weak force. Okay, when we have 6 electron and 6 positive, those forces will be weak force. Now, but still with this force we can lift an object, and that is what we are doing when we are keeping a charged pen. We have a charged pen. Okay, let's say this is charged, negative charge for example. When we are keeping a small piece of paper, what will happen? These negative charges will bring all positive charges to one end and all negative charges to other end. Okay, for the paper. Now paper's positive charges will be attracted in this way and negative charges will be repelled in this way. As these are close to each other, this force will be higher as compared to this force. So there will be a net upward force here. But as it is a small piece of paper, this can be easily lifted because the net force required have to overcome the force here. What is the force in downward direction? Mg. Why the paper is laying down? Because there is a force of mg exerted by earth. But we can easily lift it by bringing a charge, sufficient amount of charge near to this. Polarization will occur. We have positive charge here, negative charge here. This will attract with higher force as compared to the repulsive force in between negative and negative. So net force upward, and when this net force overcome mg, the paper will be lifted. Okay, so anyway, every case there will be charge, but will the charge be able to make a motion? That purely depends on, here in this case, frictional force, here in this case, gravitational force. So this is charging by induction and conduction. Okay, so here the problem is, whenever we are charging, the charged body is reducing its charge. Okay, so 12 negative charge. Now this becomes 6 negative charge, right? Number has got decreased here. But when we are charging by induction, what is happening? With one charged body, let's say we have done here. So what has happened to the charge of charged body? There is no change. We can also charge another body in the similar way. Infinite amount of charging can be done with a charged body through induction, but with conduction there are limits. That's all. Thank you.